Application Programming Interfaces, or APIs, are everywhere in today's interconnected world. In simple terms, an API acts as a messenger that allows different applications to talk to each other. Imagine ordering food online. You interact with the restaurant's website or app, which then communicates your order to their kitchen system. This communication happens seamlessly thanks to APIs working behind the scenes. APIs define a set of rules and specifications that dictate how software components interact. They provide a standardized way for applications to request and exchange data, regardless of their underlying implementation or programming language. This standardization is crucial for enabling interoperability and fostering innovation in the software development landscape. APIs have revolutionized how software is built and consumed. They allow developers to leverage pre-built functionalities and data from other applications, saving time and effort in the development process. Moreover, APIs foster collaboration and innovation by enabling developers to build upon existing services and create new integrated experiences. In essence, APIs are the building blocks of modern interconnected applications, enabling seamless communication and data exchange between different software systems. APIs are essential in today's interconnected world, driving innovation and efficiency across various industries. They enable businesses to connect disparate systems, streamline workflows, and deliver enhanced customer experiences. APIs are crucial for several reasons. Firstly, APIs foster interoperability, allowing applications built on different technologies to communicate seamlessly. This interoperability breaks down data silos and enables businesses to leverage data from various sources for better decision-making. For example, a retail company can use APIs to connect its online store with its inventory management system, providing real-time stock updates to customers. Secondly, APIs accelerate development cycles. By leveraging pre-built functionalities and data through APIs, developers can focus on building core features and delivering value faster. Instead of reinventing the wheel, developers can integrate existing services like payment gateways, mapping services, or social media platforms into their applications, saving time and resources. Thirdly, APIs enable the creation of new products and services. By exposing data and functionalities through APIs, businesses can foster innovation and create new revenue streams. For example, a transportation company can provide real-time traffic data through an API, allowing other businesses to build navigation apps or logistics solutions based on this information. In conclusion, APIs are essential for modern applications, enabling interoperability, accelerating development, and fostering innovation. By embracing APIs, businesses can streamline operations, enhance customer experiences, and unlock new opportunities in today's interconnected world. APIs are not just a trend, they are a fundamental part of the SAP ecosystem. SAP recognizes the importance of seamless integration and data exchange in today's business landscape, and has embraced APIs to empower customers and partners. Within the SAP ecosystem, APIs play a crucial role in connecting SAP systems with external applications, cloud services, and mobile devices. They enable businesses to extend the functionality of their SAP solutions, integrate with third-party tools, and create innovative solutions that meet their specific needs. ABAP, SAP's primary programming language, provides a robust framework for consuming and exposing APIs. With ABAP, developers can easily integrate external services into their SAP systems, enabling seamless data exchange and process automation. For instance, businesses can use APIs to connect their SAP ERP system with a cloud-based CRM solution, synchronizing customer data and streamlining sales processes. SAP offers a vast library of pre-built APIs, known as SAP API Business Hub, that provides access to a wide range of SAP functionalities and data. These APIs cover various business domains, including finance, logistics, human resources, and more, allowing businesses to integrate SAP data and processes into their existing IT landscape. Section 4. Making external API calls in ABAP, a step-by-step guide. This section provides a step-by-step guide on calling external APIs from your ABAP code. First, obtain the API endpoint and authentication details. Before making any API calls, you need to gather the necessary information about the API you intend to use. This typically includes the API endpoint, which is the URL that points to the API's server and the specific resource you want to access. Also, you need to know the authentication method. APIs often require authentication to ensure secure access. Common methods include API keys, OAuth tokens, or basic authentication. You'll need to obtain the necessary credentials from the API provider. Next, choose an HTTP client in ABAP. ABAP provides several ways to make HTTP requests. Two common methods are the HTTP client class, known as CL_HTTP_client, which provides a low-level approach to making HTTP calls, giving you fine-grained control over the request and response handling. Another useful class is /UI2/CL_JSON, particularly for APIs that communicate using JSON, a popular data format for web services. Then construct the HTTP request. Once you have the API details and have chosen your HTTP client, you need to build the HTTP request that will be sent to the API endpoint. Specify the HTTP method that corresponds to the action you want to perform, like GET for retrieving data, POST for sending data, PUT for updating data, and DELETE for deleting data. Set any required headers, such as content type and authorization. If you're sending data to the API, include it in the body of the request. The format of the data will depend on the API's requirements. After constructing the request, send it to the API endpoint using the methods provided by your chosen HTTP client. Next, handle the API response. Upon sending the request, the API will send back a response. You need to handle this response in your ABAP code. Check the response code, which indicates whether the request was successful or not. Common codes include 200 for OK, 400 for bad request, 401 for unauthorized, and 500 for internal server error. If the request is successful, the response will likely contain data in a specific format, such as JSON or XML. You'll need to parse this data to extract the information you need. Finally, implement robust error handling and logging mechanisms when working with external APIs. This includes checking for HTTP errors, handling exceptions to catch and manage any runtime errors during the API call process, and logging essential information about each API call, such as timestamps, request and response details, and any errors encountered. This logging is invaluable for debugging and monitoring API integrations. Section 5. Practical example: fetching exchange rates. Let's illustrate the API call process with a practical example: fetching exchange rates from an external API. We'll use the exchange rate API for this example, assuming it provides a simple JSON API for retrieving exchange rates. Here is an ABAP report example. Report z_API_call_example class LCL_HTTP_handler. Definition: public section. Methods: constructor get_exchange_rate importing AV_base_currency. Type string AV_target_currency. Type string exporting AV_exchange_rate. Type string raising CSEX_HTTP_communication_failure. End class LCL_ATP_handler implementation. Method: constructor initialize any necessary parameters or settings. End method get_exchange_rate. Data low_HTTP_client type ref2tel_HTTP_client. LV_API_key. Type string value. Your_API_key. Replace with your actual API key. The v_API_endpoint type string value quote https://api.exchangerate-api.com/v/latest/quote comma LV_response type string low_JSON_reader type ref to/UI2/CL_JSON low_JSON_data type ref to data LV_exchange_rate type string try. Construct the API endpoint. URL LV_API_endpoint LV_API_endpoint IV_base_currency. Create an instance of the HTTP client low_HTTP_client =KEY_HTTP_client Create _by_URL LV_API_endpoint. Set the request method to get low ETT client. Request set method get set any necessary headers, for example API key low TTP client Request, set header field, name =API key value =LV underscore API underscore key. Send the HTTP request, low TP client, send. Receive the response, low TP client, receive. Get the response body as a string LV underscore response =low HTTP client, response, get data, catch CX underscore HTTP underscore communication underscore failure into data, LOPA-TP exception. Handle the exception, log the error, and re-raise if necessary. Message low underscore HTTP underscore exception. Get underscore text, type E, entry. Pass the JSON response low underscore JSON underscore reader =new/UA2/KL underscore JSON low underscore JSON underscore data =low underscore JSON underscore reader. Transform underscore JSON underscore to underscore ITAB. Exporting JSON =LV underscore response end class. Start of selection. Data low underscore HTTP underscore handler type ref to LCL underscore HTTP underscore handler LV underscore exchange underscore rate. Type string low underscore HTTP underscore handler new LCL underscore HTTP underscore handler. Low underscore HTTP underscore handler. Get underscore exchange underscore rate. Exporting IV underscore base underscore currency USD IV underscore target underscore currency ER. Importing EV underscore exchange underscore rate LV underscore exchange underscore rate. Right, exchange rate USD to EUR. LV underscore exchange underscore rate. This code snippet demonstrates how to make an API call to retrieve exchange rate data. Remember to replace placeholders like your underscore API underscore key with your actual API key.